Hi, folks. I wanted to go through this simulation with you guys and try to help clarify some of the concepts behind this thin film interference. If you get a chance, I think it would be beneficial for you to go to this ophysics.com website slash L6. Or you can just find it by clicking on light up here, and it'll be under thin film interference, and you can just play around with it yourself. So what I have set here, we've got light that's coming in. Okay, this wave right here shows the incident wave coming in. The index of refraction of this medium over here is 1. We have our thin film, which has an index of refraction of 1.5, and then we also have another material behind the film that has an index of refraction of 1.0 as well. All right, so based on what we learned on the lesson over the notes, we should expect that there will be a reflection at the air right here and the film interface. And since we're going from an index of refraction of 1 to 1.5, we should expect a phase shift to occur on the reflection off of this surface. So we get, based off of this reflection, notice that this comes in, so it flips it over, so we get a half a wavelength phase shift on this. The way they illustrate it is a little funny on this, but we'll just have to go with it. The overall product that they put together works at the end. Okay, now on the back of the film, we would expect that no phase shifts occurs. Okay, so we have this strikes here, and the way they're showing no phase shift, instead of flipping it over the other way, they just make it reflect back here. So it is matched up with the incident wave hits and reflects back off and flips over instead of continuing up. On this front, we have no phase shift, so as this hits here, as this goes down and hit, it reflects back down around as this comes through. So we have a second reflection here where there is no reflected shift. Okay, so what I've tried to set here is to find the minimum thickness. I've adjusted the thickness of this film so that there's exactly a half of a wavelength in here. Okay, since we have a half a wavelength, and this that is coming in striking this, and since we are off by a half of a phase anyway, then what happens when we put these two waves together, we get this destructive pattern. So I'm going to run this real quick, and we can kind of watch as it happens. And we can see that no matter where I pause these waves at, the two reflections are 180 degrees out of phase, okay? And because this is a half of a wave thick. So what I need to do is adjust the thickness of this. So I should expect that since I have a half of wave reflection on the first surface, I need to make up a half of a wave. Okay, and I know you might be sitting there going, well, wait a second, you have a half of a wave here. Okay, but that's not true. This is a half a wave, but when it reflects back, that's an entire wave. So what I need to do is make up exactly one half a wave for the incident and the reflected. So in order to make up this half a wave here, I need this film to be 1/4 of a wave thick in order for it to constructively interfere. So if I adjust this until I'm showing only 1/4 of the wave, now I get constructive interference, and these two reflections are in phase with each other as they exit the thin film and reflect off of the first barrier. Okay, so now instead of destructive interference, we have a constructive interference pattern where the two waves match up. So in order for you to, I'm going to pause this and reset it. In order for constructive interference to occur, when you have a reflection that generates a half of a shift and another reflection that generates no shift, you need the film to be 1/4 of the wavelength of the wave. Now, I'm going to come back to this here in a little bit, but it's important to understand And remember that the wavelength of the light here in this medium is not the same as the wavelength of light in this medium. So you'll always have to calculate this wavelength value in order to figure out what this distance is going to be. So don't ever use the wavelength that you have over here in this original medium where it's incident. Okay, so let's go back to, I'm going to go back and shift this to a half a wave. All right. Now, the other thing we talked about is, let's say we have another reflection here that generates a phase shift. The way we can make that happen is, let's make this index of refraction greater than 1.5. So as I scroll this over and I get close to 1.5, so I'm at 1.49, the second I switch to over 1.5, notice that it flipped this over. So instead of destructive, we have constructive. So what happens now is that you have a phase shift on both surfaces from both reflections. And since this is a half of a wave, when the reflected wave comes back out, that makes up a total of one wavelength. So you are back into phase with the original incident wave that comes in. So now we can run that, and we can see that the two waves always overlap with each other. Okay? All right. This should make it so that if I go to a fourth of a wave now, and if I can get there a little bit further, that's about as close as I'm going to get, it looks like. So if I reduce this down to a fourth of a wave, now I have destructive interference that's generated from this. Another thing to think about, this is minimum thickness, okay? So right now, the 1/4 of the wave is destructive and half of the wave is constructive. But if let's go back to the half. Okay, we can get a second point of constructive interference if I have one complete wave here. So if I continue out, so that is 3/4 of a wave. So notice we're back at destructive interference. And then if I get one total waveform in here, right there. So I get one total waveform, and now we're back to constructive interference again. So once again, it's kind of important to play around with this a little bit. The big mistake that students usually make on these questions is forgetting that your wavelength inside of the film is going to be different than what your incident wavelength is. So a lot of times students will just use the normal wavelength of the light that I give them. So make sure you pay attention to that and understand you're going to have to calculate this. So anytime I ask for minimum constructive or minimum destructive, it's either going to be the length, or the depth of the film divided by 2, or it's going to be the depth of the film divided by 4. So what you're going to have to do is kind of play around with this until you understand which scenario results in which. Okay, that's all I've got for this video.